All right, let's dive into the world of interactive textbooks. We're looking at a web page today from Open Educational Resources slash Open Source Physics at Singapore. And this project is really trying to change how we learn physics.
Yeah, it's pretty
We're not
ambitious.
just talking about words on a page, we're talking about a textbook that lets you run simulations and play with the math behind the concepts.
It's really interesting. It all started because the team realized that traditional learning materials, they don't really connect the dots between the math formulas and what actually happens in the real world.
So instead of just memorizing equations, this project, it's all about like experiencing physics, right?
Exactly. They're building an interactive textbook with, get this, over 30 simulations,
Wow.
all about gravity and oscillations. And it's not just, seeing those concepts. It's about giving students the tools to test out their ideas and experiment virtually.
That's really cool. And I love that it's not just limited to computers.
Right.
They're making prototypes for Android and iOS devices. Super accessible.
That's so important. Think about a student who doesn't have a fancy lab to work in. With this interactive textbook, they could be exploring physics concepts on their phone, on the bus, anywhere.
Opens up so many possibilities.
It really does.
And the web page, it mentions a whole bunch of principal investigators who are involved,
Yeah.
really highlights how much collaboration is going on.
Yeah, big projects like this need lots of different perspectives, different areas of expertise. This teamwork, it's a great example of how working together can lead to breakthroughs, not just in research, but in any field, really.
It's true. Now, the web page does mention that the project's still in progress.
Right.
There's a section about publications and awards that says, to be updated.
Well, that actually reminds us that learning and discovery never really stop. It's not about reaching some finish line. It's about always looking for new knowledge, always trying to understand things better. And that's something we can all do in our own lives, always keep learning.
Love that.
Yeah.
Speaking of exploring, there's a popular tags section that gives us a sneak peek at some of the simulations they're creating.
Oh, yeah.
And some of these titles, they really got me curious. Astro Blaster Toy and Rutherford's Atomic and Thomson's Configurable Plum Atomic Model, just to name a few.
Ooh, let's break those down.
Yeah.
So, Astro Blaster toy might sound, kind of fun and simple, but it's probably using a toy that everyone knows to teach some pretty big physics ideas. Things like how objects move through the air, how energy is transferred. The students could change the angle and how hard they launch the toy virtually and then see how that affects where it lands. It's like turning a game into a physics lesson.
That's cool. What about Rutherford's Atomic and Thomson's Configurable Plum Atomic Model? Sounds like we're going deep into the atom with that one.
Oh, absolutely. With this simulation, students could probably see different models of the atom, even play around with them, not just look at flat pictures in a book. And they might even be able to recreate famous experiments, like the one Rutherford did with the gold foil. Seeing firsthand how tiny particles interact with atoms, which is how we discovered the nucleus. It's about bringing history and science to life in a way that just reading can't do.
Wow. It all sounds so exciting. It feels like we're on the edge of a real revolution in how we teach science.
What's really revolutionary is how this project focuses on active learning. It's not about just sitting there and absorbing information. It's about giving students the power to explore, experiment, really get involved with what they're learning. And that's the key to really understanding something deeply and remembering it.
Now, this project, it's all about physics, but I can't help but wonder.
You're thinking, could this work for other subjects too?
Exactly. And I want to dig into that more. But first, let's take a closer look at some of the other simulations they mentioned in this popular tag section. Some of them, well, let's just say they caught my eye.
Okay, I'm all ears. Let's see what other treasures we can find in this interactive learning goldmine. So, what were those simulations that caught your eye?
Well, there are a couple that use everyday objects to, like, show physics ideas. And I think that's a really smart way to do it.
Oh, yeah.
There's Tracker Gymnast Center of Gravity by RGS Liangxia Kwang,
Okay.
and Tracker Cupcakes with and without paper clips. I'm just picturing virtual cupcakes falling through the air. It's intriguing.
Uh-huh. Those are great examples of how this project wants to make learning, feel connected to real life.
Right.
That cupcake simulation could be looking at how air slows things down using something everyone knows, something yummy even.
Yeah.
Students might be more interested in figuring out why a cupcake with a paperclip falls differently if they can actually see it happening with, like, virtual cupcakes, right?
Yeah. Makes sense to me. And that gymnast simulation, that could be a cool way to introduce things like balance and stability.
Totally. It might even inspire some future Olympians. But thinking bigger picture, I think it's important to consider the impact this whole project could have.
You mean like the long-term effects of this kind of interactive learning?
Exactly. Imagine a future where textbooks aren't just pages you turn, but like doorways to a whole world of scientific exploration.
I love that.
This project could really change how we think about teaching and learning science.
It's like the difference between reading about how an engine works and actually being able to take one apart and put it back together virtually, I mean, you'd really understand it so much better that way.
Such a great analogy. And it's not just about understanding the how it works, but also the why. These simulations, they could help students get a real feel for the principles behind the formulas. That's so important for actually using that knowledge to solve problems in the real world.
Absolutely. Okay, so we've talked about cupcakes and gymnasts. What other interesting simulations did you see in that popular tag section?
Well, there's one called Density HTML5 Applet by Fiat, which sounds like it lets you explore how much stuff is packed into a space, mass and volume.
Oh yeah, density. That can be a tricky concept for some students.
Right.
Being able to play around with different virtual objects and see how their density changes, that would be really helpful.
For sure. And for people who love visuals, there are EJS AC Generator 3D model and EJS Direct Current Motor 3D model. Imagine being able to move those models around in 3D, seeing how all the parts work together and affect the flow of electricity.
Now that's bringing physics to life. It's like having your own virtual workshop.
Exactly. And remember, this project is all about connecting math and physics. So these simulations might look like games, but they're actually based on real mathematical models.
Right.
It's taking something abstract and making it real, giving those equations meaning.
Oh, that reminds me, there was one more simulation title that I found really interesting. Dice Throw JavaScript Model Simulation, Applet HTML5 by Fuquan Huang and Liangse Kwang.
That one could be used to explore probability and statistics, which are super important in tons of fields, not just physics.
So we're seeing a huge range here, from
Yeah.
basic ideas to more complex systems, all brought to life through these interactive simulations. It's pretty amazing to think about what they can do.
It really is. And the coolest part is that the project is open source. That means teachers all over the world can use these resources, even change them to fit their needs. It could spark a whole movement towards more exciting and effective science education everywhere.
I love that idea. Now let's talk about the team behind this project. The webpage mentions a bunch of principal investigators, which really shows how collaborative this whole thing is.
Collaboration is so important, especially in education. Bringing together people with different skills and knowledge can lead to some really creative ideas and better learning experiences. It's a great lesson for both students and teachers.
Couldn't agree more. And while this project focuses on physics, it makes me think about how we could do things differently in other subjects too.
Like, what if history textbooks let students virtually explore ancient cities? Or literature textbooks brought classic novels to life through simulations? So many possibilities.
It's inspiring to think about how interactive learning could totally change education as a whole.
It really is. Now, before we get carried away with all the exciting possibilities of the future, let's come back to the present for a moment. We talked earlier about how this project is still a work in progress, with those sections on publications and awards to be updated.
Right, that's a good reminder that learning is a journey. We should always be looking for new knowledge and trying to understand things better.
Exactly. And that's true for everyone, whether you're a student, a teacher, or just someone who loves to learn like you.
Speaking of lifelong learners, I'm curious about your thoughts on the role of interactive learning for personal growth and development outside of school.
That's a great question. I think interactive learning is especially valuable outside of a traditional classroom because it lets us explore things we're interested in at our own pace and in a way that really grabs our attention. It can rekindle that love of learning that we might have lost touch with.
And with so many online resources available these days, there are so many ways to learn on your own. We don't have to depend on formal institutions anymore to get knowledge.
Absolutely. The whole world is like a classroom now, and interactive learning tools can help us unlock its secrets.
Before we wrap up our look at this amazing project, there's one more detail I want to point out.
Okay.
We've seen a lot of simulations with tracker in their titles, like tracker reaction time, $50 note drop,
Mm-hmm.
and tracker rate of change, decelerating bicycles with model by Evergreen Sektan Kim Kia.
Right. Tracker is a really cool tool that lets you analyze how things move in videos. You can track their position, speed, and acceleration over time. It's often used in physics.
So these tracker simulations are probably using real video footage to create those interactive experiences. Another clever way to connect theory and reality.
It's all about showing physics in action, using situations that people can relate to. Instead of just abstract diagrams in a book, students can see these concepts playing out in real life, which makes learning more engaging and meaningful.
I can picture students dropping dollar bills and analyzing how bicycles slow down, all in the name of science. It's a far cry from those old textbooks.
For sure. And it shows how creative and dedicated these teachers are, always looking for new ways to make learning fun and engaging.
This deep dive has been amazing. We've explored a project that's not just changing science education, it's making us rethink what learning can be.
It reminds us that education isn't about memorizing facts or passively taking in information. It's about actively exploring, experimenting, and really wanting to understand the world around us.
And with tools like these interactive simulations, learning can be an exciting adventure for anyone, no matter how old you are or where you come from.
Absolutely. Now, before we move on to our final thoughts, there's one more thing I think we should discuss. You said earlier that this project focuses on physics, but what does that mean for other subjects?
That's a great point. Could this approach, this mix of simulation and inquiry, be used in other fields too?
That's exactly the question I want to explore next. What if we could bring this kind of interactive learning to history, literature, art? The possibilities are endless.
We've been really diving deep into this interactive textbook project, and it's exciting to see how it could really change science education.
It is inspiring, for sure. But like with anything new, there are always some bumps in the road, things to think about carefully.
That's true. It's not enough to just create these cool tools. We have to use them the right way.
Yeah, exactly. So maybe we should talk about some of those challenges, those things we need to consider.
Yeah, for sure. One thing that jumps out at me is access. Even though more people have internet now, there are still places where students can't easily get online.
That's a big one. We can't say we want everyone to have good education if they can't even get to these resources.
Right.
We have to make sure everyone can use these tools no matter where they live or how much money their family has.
Absolutely. And even if the internet is good, some schools might not have the computers or the software they need.
You're right. And then there's the money part. Setting up and keeping these technologies running, it can be expensive, especially for schools that are already struggling.
So it's not just about making the tools, it's about making sure everyone can actually use them.
Exactly. And we can't forget about the teachers. They need training to learn how to use these tools well and fit them into their lessons.
It's not like you could just give a teacher a tablet and say, okay, go be interactive.
Haha, yeah. There's a learning curve for everyone, teachers and students. We need to give them support and resources to make this change go smoothly.
And I could see how all these cool features could be distracting too.
Oh, yeah.
It's easy to get caught up in the bells and whistles and forget about what you're supposed to be learning.
That's a good point. It just means we have to design these tools really carefully and make sure they're helping students learn, not making it harder.
So it's not just about the technology itself, it's about how it's used. The teacher is still super important in all of this.
Definitely. We need teachers who are good at guiding these interactive learning experiences, making sure students stay
It's
focused.
like technology is a tool, it can't replace a good teacher.
Exactly. And like any tool, you have to know how to use it the right way.
So even with these challenges, are you still optimistic about the future of interactive learning?
Oh, definitely. The potential is just too big to ignore, but we have to be smart about it, work together to make it happen.
So that means figuring out the access problem, the cost, and how to train teachers.
And it means getting everyone involved in the conversation. Teachers, students, parents, the people who make decisions about education.
We all need to work together to create a learning environment that's exciting, effective, and fair for everyone.
That's a goal worth fighting for. And even though there might be some bumps along the way, I think we're moving in the right direction.
I like that. Well, on that hopeful note, I think it's time to wrap up our deep dive into this amazing world of interactive textbooks.
It's been fun, hasn't it? Lots to think about.
We've seen how these tools can really change how we teach and learn science, making it more exciting, more accessible, more connected to the real world.
And we've talked about the challenges, how important it is to do this the right way.
So, as we finish up, I want to leave you with a question to think about.
Ooh, I love a good question.
We've talked a lot about how these interactive tools can affect students, but what about the teachers? How could these changes change the way teachers do their job?
That's something to really consider. As we use more and more technology in the classroom, we have to think about how it can help teachers become even better at what they do.
I hope you'll keep thinking about this. Keep learning about interactive learning and see how you might use these tools in your own journey, whether you're a student, a teacher, or just someone who loves to learn new things.
Don't forget the most powerful tool you have is your own curiosity. Keep asking questions, exploring, and never stop learning new things.
It's been awesome diving deep with you into this topic. Until next time, keep exploring and keep learning.
See you next time. Happy learning.